Good evening, everyone. Welcome to the NPTEL course, Basic Electrical Circuits. And this is the week one problem solving session of the NPTEL course, Basic Electrical Circuits. And week one is about Introduction to Circuit Elements and Sources. My name is Teja Golla. I'm a fourth year research scholar working under Dr. Santanu Kapat at Embedded Power Management Lab, IIT Kharagpur. Let me share my screen. I'll give a brief introduction about this about myself as well as about this course and how these problem solving sessions go on. So this is the week one of this basic electrical source NPTEL course, and I hope you are able to see my screen. Can anyone please confirm?
Yes, sir.
Okay. Yeah. So let me go to full screen. Okay. So basic electrical circuits, and this is the week one, which is introduction to circuit elements and sources. And there will be 12 weeks, as I have already mentioned. So each week we'll have this problem solving session on the Mondays from 6 p.m. to 8 p.m. And yeah, I expect to see more students every week. So just a brief introduction about myself. Sorry. So I am Teja Golla and I'm a fourth year research scholar. And previously I have conducted two such NPTEL sessions in my third year. In the third year, first semester, I have taken one NPTEL course, Digital Control in Switch Mode Power Converters and FPGA based prototyping, and all these are uploaded to my YouTube. And this year in the spring semester, I have taken network analysis, which is quite similar to basic electrical circuits. Both are almost the same. So if you want to go through, you can go through that. I'll give the link to my YouTube channel, and those videos are already uploaded there. So you can go through these lectures anytime. So this is some basic introduction about myself. So coming to this course, basic electrical circuits, I'll give you some basic outline about the course, what is going to be taught by sir and what I'll be going to teach in these sessions. So we have 12 weeks, as you know, in the week one, which is today's week, we'll have introduction to circuit elements, which is just to give some brief introduction about what are the circuit elements and what type of sources are there and what is the difference between them, and to get some basic understanding about these sources and circuit elements. And then in the subsequent weeks, we'll see about elements connected in series and parallel and some control sources and about circuit analysis method as well as nodal analysis and mesh analysis, and we'll eventually go to two port networks. And then coming to week 7, we'll have this two port parameters continued, and then we'll go into op amp circuits, which is very crucial and very important in your upcoming courses. And op amp is one such important topic which you will learn in electronics for EC people or as well as EE people, and one should have very thorough understanding about op amp. Then we'll eventually go to first order circuits, and then we'll see first order circuit with time varying inputs, sinusoid inputs, and we'll see how to get the output expression. And then we'll move on to second order system, what is the natural response of the second order system, and then we'll move into the maximum power transfer theorem. But today we'll be discussing about the week one, which is introduction to circuit elements as well as different sources. So coming to the problem solving session, as I have told, this problem solving session will happen every Monday from 6 p.m. to 8 p.m. If I'm unable, not available, then I might shift to Tuesday, but you will be informed about it through mail, and that part I'll take care. So first, whatever I was saying, I will try to first revise relevant theory for say first 40 to 45 minutes. Then uh, we can have some doubt clearing session on the concepts that we have covered in this 45 minutes, and then we'll solve some previous year assignment problems, which might be 1 hour 25 minutes to say 1 hour, this going from 45 minutes to 1 hour. So we can cover both the concepts as well as solve few problems, which is very crucial, as I was explaining previously. And this is the Zoom meeting link. So every week we'll join in the same Zoom meeting. However, there is one issue with the Zoom meeting. will be of 45 minutes. So after 45 minutes, this meeting will be closed, and I'll open the same meeting again. So in the next 45 minutes, we'll join in the same same Zoom meeting, and then we'll continue. Again, after 45 minutes, it will end because the restriction on the Zoom meeting is up to 45 minutes, but we'll try to join using the same link every 45 minutes. As this is 1 hour 20 minutes, I think we have 40 minutes. So we will conduct this session three times. So 6 to 6:40, 6:40 to 7:20, 7:20 to 8. So we'll use the same Zoom meeting, same link. And then we'll record the session in each of these three meetings. So we'll have three such meeting of 40 minutes. So once we conduct this session, I'll then consolidate all these three recorded videos and make a single video and upload it to my YouTube channel. And you can access this from my YouTube channel. Okay. So as I have said, all these problem solving sessions will be recorded and then these will be uploaded to my YouTube channel. So as I have promised, I will try to upload by Tuesday night, and I try to keep this as a habit so that you will get the video by Tuesday night and you can go through this video before your final assignment submission. And here I have mentioned link to my YouTube channel, and I'll also mention this in the chat box so that you can access. And I'll be creating a Google Drive where I'll be uploading all my lecture notes in this Google Drive. So you can access this Google Drive. So once I upload the video in the YouTube, I'll also try to upload the lecture notes in this Google Drive, and you can directly access it from there. So yeah, that's some basic introduction about how this problem session happens. And one more important thing. So these problem solving sessions are of 2 hours. So I hope I'm audible. Can anyone please confirm?
Yes, sir.
Okay. So there might be some network issues, as I hope there will not be, but if there is any network issue, then I'll not know. So I'll ask every 10 minutes once so that I'll know that my network is proper and you are able to hear me. So these problem solving sessions are of 2 hours each, 2 hours. And as we have 12 weeks, 2 hours per week, and we have 12 weeks. So we'll have 24 hours. Right. And then there will be one additional 1 hour session. This is before the final exam. So if you have any doubts, we can discuss in this 1 hour. So total we'll get around 25 hours problem solving session. And all this 24-hour means 12 videos plus another one video. All these 13 videos will be uploaded to my YouTube channel and they'll be available there. Yeah, so before we go into this today's week, I'll just want to share this details. So these are the details I'm mentioning in the chat. So I have mentioned three links. One is my YouTube channel link. So you can save that YouTube channel link where I'll be uploading my YouTube videos. So you can bookmark that and you can check constantly. By Tuesday night, I'll try to upload. And this is the link to the Zoom meeting. So this meeting ends after every 40 minutes. So even if it ends at, I'll open this Zoom meeting again and please join it back because there is 40 minutes restriction on each Zoom meeting. So we cannot have long meetings in the same. So I'll try to keep it as continuous as possible so that you will not feel discontinuity. And finally, I have mentioned one more link, which is the drive to access the notes. So in that, if you open the drive, you will see it empty because currently I have not uploaded anything. But after today's session, I will upload week one notes, similarly week two notes. And if I use any other material, say any reference books, then I'll try to upload it in that Google Drive so you can directly access it from there. So keep try to save these three links, and these will be same and it will not be changed throughout this entire course. So I suggest you to check these links. And can anyone please confirm, are you able to access these links? And all three links
Yes,
should
sir.
work. Yes. Okay.
Yes, sir. Links work.
Okay. 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 Then, yeah. If you have any doubts until this point, you can ask. Else, we can go into today's technical summary discussion. Any doubts till now?
Sir,
Yes.
sir, we
Yeah.
got three links to
Yes.
technical session for three links. You are
Yes.
accessing on Monday,
Yes.
and Friday one session is there, and Tuesday one session is there. That will be taken by some other person or you only.
Yes. Yes, yes. So good question. There are three people who will be taking this problem solving session for this course. So you can join any of these three or any of these two or all three. It's up to you. If you are like free, you can join all these three sessions, and we may not solve the same set of problems because I am solving from assignment, some different assignment, and they may be solving from the different assignment or probably the same assignment. So it is not mandatory to join all these three because it will take 6 hours of your time. So if you are free and if you are willing to join, it is okay. But I recommend you to join at least any one of these three sessions because these will be helpful to you. But it is not mandatory to join all these three. And in all these three, we'll have some discussion and summary sessions and doubt clearing session as well as problem solving session. Yeah, and all these three happen in every week. So whatever I'll be covering in week one, they will also be covering in the week one. But if you have some doubts or if you are say busy on Monday and you are unable to join, then you can join Tuesday or Friday according to your convenience. But I would recommend you to join at least any one of this session every week so that it will be helpful to you. I hope this is
Uh,
clear. Okay.
yes, sir. And then
Any
one
yeah.
more thing, sir. Every Wednesday we completed our assignment, sir.
Okay.
Uh, So in Sunday, if it possible to explain 1 hour in assignment problems means it will be more useful for us.
Okay.
Instead of seeing the theory theory PDF,
Okay.
if you explain means it will be more useful for us.
So you are saying you are asking me to solve more problems and not more theory.
No, sir. In every Wednesday we completed our assignment problems.
Okay.
So in Sunday you just take that 10 to 12 sums and solve it for us means it will be more useful for
Okay,
us.
actually, one issue is there. I would also prefer to do that, but we get a like notification not to solve this year assignment, so we are not allowed to do that. But if you have any questions in this assignment, you can always ask in the forum where we can always address. But it is told to us not to solve this year assignment problems and upload it to the YouTube. So we got that strict guidelines. Else we would have done that. But yeah, anyway, whatever problems that we are solving are from previous year, so they're almost or maybe close to each other, like the I would say maybe sometimes it will be of same model, but a different number they will be using, but the concept will more or less remain same. So if you have any doubts, you can ask. Say you can ask me that question. Say this circuit is there, resistor is there, capacitor is there. So how to solve for current or voltage? You can ask me. But we are actually not allowed to do that. So that's why we cannot do that.
If the submission date is completed means if we ask in the live session means it will be possible, sir.
Yes, yes, yes. If you have any doubts, you can ask, but I cannot open that assignment and solve that. If you have, say, one or two queries, say you try to solve out of 10 to 12 problems, maybe you have solved some half or two-third of the problems, and you have some doubt in some of the question, then you can ask me, sir. Say there is one circuit which consists of resistors and capacitor like this, and parallel one inductor is connected. So if input is something like this, and they're asking what is the output, then you can ask me, then I'll try to solve. Also, I'll try to solve a few of the past year assignment problems. So if you find a similar problem from there, then you can mention, sir, can you explain this problem, which might be of like of the same concept but different numbers. So we can solve that problem, and your concept will be clear.
Okay, sir.
Okay.
Thank you.
Yes, and someone has asked, three-phase system theory is not part of this basic electrical circuits. Yes, three-phase is not there. So whatever I have mentioned in my earlier slides, only those will be covered in this session. So just have a look. This is from week 1 to week 6, we'll morely discuss about circuit elements, sources, and few circuit analysis methods, nodal analysis, mesh analysis, and then different circuit theorems like Kirchhoff's current law, voltage law, and superposition theorem, and some additional theorems. And these are more generic. These are not only for these circuits, these are valid for any other circuit. So we'll learn about these theorems, and we'll consider some RLC network and apply on that circuit. But it is not that it is only applicable for RLC. These are generic theorems which are applicable for other circuits as well. But we'll use RLC with voltage and current sources to understand that concept. So we'll consider this application to understand that particular concept, but it is not just restricted to this circuit. And in the week 7 to week 12, we'll discuss more about two-port parameters, op-amp, and first-order circuits as well as second-order circuits. And if they have different type of inputs, then how we are going to address and what type of concept we'll use to solve them in a easier way. So we might be learning 2 to 3 theorems, but it might so happen for a given circuit, theorem 1 will give the result in like fewer steps. We should also understand which theorem to apply and where to apply, which is also a very important thing, as these exams have a time limit. So you should try to reach that solution in the smallest possible way. So you have to learn all the concepts, but you should also know which concept to be applied where, so that the problem can be solved in a fewer steps. So that we'll get into once we start solving the problems. So yeah, first let me just give a brief summary about what we'll be solving. So first I'll just give a brief summary of what is taught in week 1. If you have any doubts, then you can ask, else we can proceed with our discussion. Any queries?
No, sir.
Okay. So we'll try to go according to the time. So I'll try to summarize, and I might not cover all the concepts that sir has taught, because sir has taught for a few hours and I cannot cover everything in this session. But I'll try to cover all the important concepts which are needed for problem solving session. And if I miss something and if you have doubt, then you can ask, and then I'll cover that concept as well. And if I make any mistake, you just notify, so that we'll not waste time uh, by continuing that mistake. So if I make any numerical mistake or something error, you just notify, because I'll be uploading this in the drive, so that people will not go through that. So if I miss anything and if I make a mistake, please try to correct me. So yeah. So first, I'll give some basic understanding about what is an electric circuit. So it is just a interconnection of multiple elements. So first we need to understand the nomenclature as well. So whatever words that we use, you should have proper understanding about that. So electrical circuit. So it is just a interconnection of elements and sources. So it is a interconnection of elements and sources. So now again, this element, what is an element? Element can be a two-terminal element, or a three-terminal element, or a four-terminal element. If you say resistor, capacitor, inductor, they are two-terminal elements. If you consider mutual inductor, it has four terminals. So element can have greater than or equals to two terminals. So if I say two terminal, it is resistor, capacitor, inductor, as you know. But there can be a two-port network. Uh, sorry, not two-port network. There can be a mutual inductor which has four terminals. So it can be more than two terminals, and that can be considered as an element. And sources, coming to sources, what type of sources do we know? We know two types of sources. One is the voltage source, and another one is the current source. So we'll get into that deeply once we cover each of these concepts. So I can consider one circuit something like this. Say here is one resistor, there is a capacitor, and here I have considered one resistor and then one inductor, and say here I have considered one voltage source, and maybe here I have considered another current source. Say this is some voltage V1, R1, R2, C, L, and say I, I1. So now, what is a node? So node is just an intersection of two or more elements. So if two or more elements are connected, then it is called a node. So at least three elements should be connected to that point, or maybe two. So if R1 and R2 are connected and as well as C, so it is you can name it as node N1. And if you see this point, this element or source is connected, so you can name it as node 2. So what is a node? Node is an interconnection of two or three elements or sources. So it is an interconnection of two or more elements or sources. Elements slash sources. Now what is a loop? Loop is a closed path. So when we say loop, it means it is a closed path. So loop means any closed path which consists of elements and sources. So now if I say here, this is one loop, right? So this I can call L1. This is another loop, L2. And this is another loop. And this is also another loop. So this is also another loop. And the outer bigger one is also a loop. So loop it can be any closed path, but it has to be a closed path. Okay. So loop is basically a closed path. Maybe I'll bring this down. So loop is a closed path. It cannot be open, consisting of elements and sources. Okay, so this is just a brief introduction about the terminology that we will be using throughout this course. Now we can go to Kirchhoff's current law and Kirchhoff's voltage law. Do you know about Kirchhoff's current law and Kirchhoff's voltage law? So sir has given just a brief introduction about KCL and KVL. Are you following? Hello?
Yes, sir.
Yes,
Yes.
sir.
Okay. So Kirchhoff's current law means we'll apply this at a node. So now we know what is a node. So we'll apply this at a node. Yeah. So let me consider one example which sir has considered already in his lecture. So I am using the same one. So sir has considered one circuit like this. So this is connected here, and sir has connected another element, something like this. Okay. So this is I1, I2, I3, and I4. So KCL can be stated as so first of all, this is a node, right? Two or interconnection of two or more elements, right? So this is a node. So KCL is applied at any node. So and it says the summation of the currents entering the node is equals to summation of the currents leaving the node. So I can state it as sum of currents entering the node is equal. Sir, this video is also available in the recording. Yes, this video will be available in the recording, and in the chat I have mentioned my YouTube channel link where this will be uploaded by every Tuesday. So you can also go through this session there. Is equal to the sum of currents leaving the node. So here I have considered four currents which are entering. So summation of the currents entering is equals to summation of the currents leaving. So what is the summation of the currents leaving the node? Zero, because no current is leaving the node. So here I can write I1 plus I2 plus I3 plus I4 is equals to 0, because in this case no current is leaving. Say if one of the current is leaving, then summation of these three currents will be equal to the summation equal to the current of the fourth branch. Sir, I missed previous videos. How can I able to recover this syllabus? Sir, why capacitor inductor are zero in DC supply circuit? Yeah, Kamaki, I'll come to your question in the like in this lecture. We'll try to cover that. So someone has asked, sir, how to recover if they have missed videos. So do you mean the lecture videos, or do you mean this particular session? If you have missed this particular session, this video will be available in the YouTube, and I'll upload it to the YouTube channel, and the link of it is mentioned in the chat. Maybe I can mention it again. So I'm writing in the chat box. So whoever has missed it, you kindly check. Did it send, or just a minute? I'm sending. Yeah, I have sent the message again. You try to see. So this is all about Kirchhoff's current law, where we deal with the currents. Then we'll go to Kirchhoff's voltage law, and this is applied in a loop. So KCL is applied at a node, and this is applied at a loop. So let us consider one loop. So I have considered four elements, and say, let me consider the voltage's polarity. So I have considered one loop which consists of four elements, and KVL says that the sum of the voltage in the loop will be zero. So sum of the voltage drop or voltage drop or rise in a loop is zero. So we have to start from a particular point, and we have to traverse through the loop and reach the same point. And we should not uh, do it multiple times. We have to do it only once, and we have to come back to the initial point. Okay. So here, say I'll consider this as my reference. Say you are free to choose any one of the terminal as ground, unless it is mentioned. So I'm starting from this node, and I'll go in the clockwise direction. Say I'll go to A, I'll go to B, then I'll go to C. So you know, uh, when we are going from this node to this node, whether the voltage will increase or decrease depending upon the polarity. So say this node is node O or node G. A is at a higher potential than O, because A is at positive and this is at negative. So when I go from O to A, I am going to a point which has higher potential. So it will be plus V1. And when I'm going from A to B, A is at a higher potential, B is at a lower potential. So there is a decrease in the potential. So there will be one minus sign, minus V2. Then from B to C, again, there is a decrease in the potential. So because B is at a higher potential, C is at a lower potential. I am going to a lower potential point from a higher potential point. So there is a decrement in the voltage. So minus V3. And again, from C to O, there is an increment because O is at a higher potential compared to C. So plus V4. So the summation of this will be equals to 0. So is it clear until this point? KCL and KVL, or do you have any doubts? Hello. So KCL is applied for a node and KVL is applied in a loop. So KCL says the sum of the current entering the node is equal to sum of the current leaving the node, and KVL says the sum of the voltage drop or the voltage rise in a loop is 0. Yes, sir, clear. Okay, then we'll go to, yes, sir, clear. Okay. So then we'll go to sources and then we'll go to the elements later. So first I'll discuss about voltage source, then I'll discuss about the current source. So today we are going late because I had to give some introduction, but it is still okay. Sir, can you please explain me once? Yes. So KCL, these are circuit laws. These are called circuital laws, and there are two types of laws. One is KCL, another one is KVL. So KCL says, and KCL is applied at a node. That's why I have mentioned here. It is always applied at a node. So you will consider any node, and then you say sum of the currents entering the node is equal to sum of the currents leaving the node. So here I1 is entering, I2 is entering, I3 is entering, I4 is entering. So summation of this is I1 plus I2 plus I3 plus I4. And what is the value of the current that is leaving? No current is leaving. So it is 0. So summation of the currents entering the node is equal to summation of the currents leaving the node. And then KVL. KVL says sum of the voltage drop or rise in a loop is 0. So this has to be happening in a loop. So we'll start from one point, we'll traverse through the loop and reach the same point in the end. So that completes a loop, right? And you should not cross this point multiple times. That is not allowed. Okay, so we have to start with that point and end with that point. That's it. So once we are traversing through this loop from O to A, if I'm going, it is rise in the potential, so plus. From here to here, it is decrease in the potential, so minus. Again, from here to here, it is a decrease in the potential, so minus. And from here to here, again, there is an increment in the potential, so plus. So there is less than a minute. After this minute, this meeting will end automatically because 40 minutes are over. I'll open this meeting again, try to join using the same link that I have mentioned in the chat. So this Google Meet, Zoom Meet link will be used throughout this entire course. So once this meeting ends, please try to join back and then we can continue our session. So I hope it is clear. Save those links so that you can access it at any time. So once this meeting ends, please try to join back. We can continue our discussion. I hope that is clear, right? It might end any time soon.
Yes, sir.
Okay, okay. And once we come back, we'll discuss about sources. So the first one is voltage source. So someone has mentioned. Okay. So we'll talk about voltage source. So what is a voltage source? So voltage source basically it says it's a source and it's of voltage, not current, which means the voltage is constant. Let me. Someone has asked one query in the chat. Okay, yes. So voltage source. So there are independent voltage source, there are dependent voltage source. So what are dependent voltage source that we'll discuss in the upcoming lectures. So the meaning it says dependent means the value of that voltage source is dependent on something. Independent voltage source means it is independent of anything. So it is fixed and we can represent it something like this. So plus implies the positive terminal and minus implies the negative terminal. So this can be A, this can be EV. Say this is 3 volt, then we say VA minus VB is 3 volt. Sir, will this video have a, someone has mentioned, sorry, someone, sir, will this video be able to see in our profile where we get the normal lecture notes? I am not sure whether they will give you, but I think they will circulate you these YouTube video lectures because we'll be submitting these video lectures to the NPTEL people. Even if you don't have that, like get the access, I'm mentioning this link in the chat box. So please try to save all these three links, and these are important. So you can save the text somewhere and you can access it directly from here. So no need to wait for the NPTEL people to respond. You can directly access it from here. Okay. So now we can say VA minus VB is equals to 3 volts. So it is always 3 volts irrespective of the current. So voltage source can supply the current, which means the current is coming out from the voltage source, or it can consume current, which means that it is drawing current. So the current is entering into the voltage source. So I can be anything, but VA minus VB is always 3 volts. So let us understand by drawing IV characteristics. So IV characteristics shows the uh, change of I with respect to V or change of V with respect to I. And these are very important curves even in your electronic circuit or anywhere. These IV characteristics are very, very important. So uh, the shape might be differ, but the application is irrespective of the field. In majority of the field, they have IV characteristics to understand the behavior of current and voltage of that particular source or element. So what I said, the voltage is same. So V is always the same irrespective of current. So how it will be? It will be something like this. So V is always same irrespective of the current, and this is equals to 3 volts. So this is the IV characteristics of a voltage source, which means it is parallel to y-axis. Because we have said that the voltage is always same, meaning the x coordinate value is always same, and irrespective of the y coordinate, which means it is parallel to y axis, because the x coordinate of this is 3 volt, because it is 3 volt. If it is 5 volt, then it will be shifted and we'll have something called 5 volt. If it is minus 3, it can be minus 3 also, then it will be on the left hand side of this y axis. So this is all about voltage source. Now if you go to current source, so these are analogous to each other. Voltage source means the voltage is constant, current source means the current is constant. So now you know what is a voltage source. uh, Something which maintains the voltage, and it will supply the current or it will draw the current. And you know the basic example of voltage source, like you might have seen battery, right? 1.5 volt battery or 12 volt battery, 18 volt battery, or your car battery. All these are voltage source. But what is a current source? We do not actually directly get a current source like we get the voltage source. Current source has to be made using some circuit elements. So any large inductor can be considered as a current source. And if you have studied this electronic circuit, then you might have also known current mirrors. So in that current mirrors, they use MOSFETs like a current source. So it is another application of MOSFET. So using MOSFET, so using MOSFET, current source is made. So it is not directly available like a battery or a voltage source. Current source has to be made in a circuit. A circuit with large inductor will work out like a current source, or a MOSFET can be uh, connected in such a way that it can act as a current source. But for MOSFET, the current will be limited. But for inductor, the current can be higher. So current sources can be drawn like this. So if is arrow within a circle shows that it's a current source, and this is AB, say this is 5 amperes. Okay. Sir, what is mean by MOSFET? So if it is not yet covered in your curriculum, let it be. You will learn in the future. But it's a semiconductor device. You might have seen transistors. Say you are using a mobile phone and it consists of a processor. Say if it is a iPhone, it consists of M processor or A12 bionic chip, whatever. And if it's a Android, you have Qualcomm processor, this processor, that processor. So all those processor consists of transistors, right? You might have seen that Apple, this chip has 10 billion transistors, this transistor. So and this is a transistor, and transistor has multiple devices like BJT, MOSFET, and MOSFET is one such transistor, not the only transistor. So transistor is a family, and MOSFET is a sub part of that family. So there are multiple transistors, and MOSFET is widely used in the processor, digital processor, the mobile phones or your laptops, everywhere where you see a digital processor, MOSFETs are there, and they are in millions and billions, not just one or two. So here, say this is A and this is B. So the current is 5 amperes. So if again we have to draw the IV characteristics, how it will be? Say This is my I, this is my V. So here I is constant and voltage can be anything. So VAB, so this is the VAB. This can be anything, but the current is always 5 amperes. So it will be something like this. So this is 5 amperes. So no matter what voltage you apply across this current source, it has to supply the same amount of current. So it would be somewhat difficult to imagine because current sources are not practically available. Whereas voltage source, you can imagine that a battery is a voltage source, but it would be somewhat difficult to accept that there exists something called current source because it is not directly available. Neither we have used in our life directly. So it may be difficult, but you just try to understand that no matter the voltage across the current source, it has to supply the same amount of current, and then only we call it current source. So this is again, as you can see, parallel to x-axis because the current remains same irrespective of the voltage. And one important thing, voltage source cannot be short circuited. Why? If you short circuit, basically what you are doing, you are connecting a voltage source of, let me write it here. So this is very important. Voltage source cannot be short circuited. Voltage source cannot be short circuited. And current source cannot be open circuited. Got it? Why? If a voltage source is short circuited, say I have connected and this will become a loop, right? So if it is a loop, I'll have to apply KVL. And what does KVL say? The sum of voltage drop in a loop is zero. So if it is short circuited, what is the voltage in the loop? It is 3 volt or minus 3 volt, and it is not zero, right? So KCL will fail if you connect a voltage source in short circuit way. And similarly, okay, what is short circuit and what is open circuit? Okay, nice question. Say open short circuit means you are actually shorting. Short means connecting. So voltage source short circuiting meaning you have a voltage source like this and you are forcefully connecting these two. Basically, what you're doing is you are connecting the positive terminal of a battery with the negative terminal of the battery. It will blast. So we should not do. Why? KCL will fail. Why KCL will fail? Say this is plus, sorry, this is minus, right? This is minus, this is plus, right? If you apply 3 volt and if I start from A to B and if I go from A to B, what is the voltage? Plus 3. And from B to A, it is the same. So plus 3 is equals to 0 because it says the sum of voltage rise or drop in a loop is 0, but it is not true, right? 3 is not equals to 0. So here KCL will fail. So if a voltage source is short circuited, what will happen to the resistance? So first of all, you cannot connect a voltage source in a short circuit theoretically, but in the practically, if you connect a voltage source in a short circuit fashion, huge amount of current will flow. Why? Because this wire you are connecting through a wire, right? So this will have very slight resistance, say 1 milliohm. Then what is the current? Current will be 3 volt by 1 milli, which is 3000 amperes. So lot of current will flow through that path and the battery will blast. So you should not do. And theoretically also it is not possible because the KCL will fail. So any circuit which shows this voltage source short circuited is not correct, and you should not also do it practically because it will blast. Now current source cannot be open circuited. So let me first write this here. KCL will fail if it is short circuited. Sorry, KVL. KVL will fail. Here KCL will fail. Why? Say I have a current source and I have open circuited, meaning it is open, it is not connected to anything. Closed means you are shorting the two terminals. Open means the two terminals are not connected to anything. So this is short circuit. Basically, short circuit meaning you are connecting both the terminals. So it might so also happen in your home. You might have seen that some short circuit has happened and the fuse is gone. It happens when there is huge rush in the current and the fuse cannot uh, allow current more than a certain limit. So if the say some device is gone, say heater or geyser is gone and it is drawing a lot of current, that fuse will be gone to protect the grid. So it will not provide more than certain amount of current. So if it provides, first of all, the geyser or the heater will be gone. So that's why the fuse is kept to protect the devices as well as the grid meaning from where you are getting the supply. So that's why you might have seen that in few of the houses, if there is some short circuit, the fuse will be gone. So that's what we call when there is huge rush in the current, and this is called open circuit. Open circuit meaning it is not connected to anything. So here KVL will fail. Why? This is a, say, considering this as a node, the current entering should be current leaving, right? But the current is not leaving. So here KVL will fail. So that's why current source cannot be open circuited. It should always be connected to some circuit. Voltage source, it cannot be short circuited. It can be open circuited, but it cannot be short circuited. Whereas current source can be short circuited, but it cannot be open circuited. So these are some of the important things that you should keep in mind. So is it clear until this point? Any doubts further? Yes, clear. If you have any doubts, you can ask. Else, we'll move into elements, and we'll discuss about four elements. One is the resistor, inductor, capacitor, and another one is the mutual inductor. But before going to mutual inductor, which is a little bit tricky, first I'll talk about resistor, then capacitor, then inductor. So resistor, capacitor, inductor, or maybe we can use different colors. Sorry. Sir, please explain short circuit and open circuit. Yes. So, say we have a two terminal device. Short circuit meaning you are connecting both of the terminals. Say in the case of voltage source, you are connecting terminal A with the terminal B. So basically, you are connecting the two terminals of the device with themselves. So that is called short circuit. Basically, what you are doing is shorting. Shorting means connecting through some wire. So you are shorting terminal A with terminal B. So you are calling this as short circuit. And if you do this for the voltage source, I'm sorry, I'm really sorry. This is KVL and this is KCL. Sorry, I made a blunder. So this is KVL will fail. Here KCL will fail. Sorry. So if the voltage source is short circuited, if you apply KVL in the loop, if you go, the summation of the voltage should be zero, but you are getting a positive voltage and that cannot be equal to zero. So KVL will fail. And in practical, if you are short circuiting, huge current will flow and the battery will get damaged. So that's why you should not combine the two terminals of a battery. Similarly, current source is not practically available, but assuming that we have a current source, it cannot be open circuited because say this is some node. First of all, this is not a node because two or more elements are not connected. But assuming any path, current entering that node should leave that node, right? But current is not leaving because you are not providing any path for it to go. So current cannot directly, like, this current source is supplying current and the current cannot stop here because the KCL will fail. KCL says the current entering the node should be equal to current leaving the node. So here KCL will fail. So that's why you cannot open circuit. Open circuit meaning these two terminals are open. Open in the sense they are not connected to anything. So these are the terminology that we use. So whenever we say something is open, it means it is not connected. If we short it, it means that we have connected to some other terminal. Sir, can you please explain some problems which are related to assignments? Yes, yeah. Hema, just a few more minutes. I'll just cover this resistor, capacitor, inductor, and coupled inductor, maybe 10-15 minutes, and then I'll move on to assignments because these are some things that are needs to be covered so that if you have any like some confusion, then it will be clear. Okay, thanks. Yeah. I'll try to keep it simple and then we'll move to problem solving session. So resistor meaning something like this. Say the voltage is plus minus V and the current is I and it is R. Then we have the relation V is equals to IR, which is Ohm's law, which you all know. Okay. And then for capacitor, sir, in the voltage source, we have to connect resistor in series. Why so? So the same issue. Say uh, like it is not mandatory to connect a resistor in series. Say here, this is a voltage source, and if you want to short circuit, say you have connected through some wire, and the wire resistance is 1 milliohm, which means the current has to be 3000 amperes, which is very huge. That's why the battery will be gone. If we connect some resistor, what it will do, the resistor will limit the current. Say if I have considered 1000 ohms, then what is the current? 3 milliamperes. So sometimes we connect a resistor so that the current drawn by the circuit will be limited by that resistor. Say uh, if I have a circuit here, something like this. Say I'm varying this resistor. When I put this arrow, it means that resistor is varied. Say here I am considering 1 kilo ohm and say this is 1 volt. So if R is say 1 kilo ohm, I, if R is say 0 ohm, then what is I? Here I is zero point 0.5 milliampere. Here I is 1 milliampere. So when R is 0 ohm, the current is only flowing, I mean, this is just shorted and the current is limited by this resistor, right? So if I have not connected this resistor, then what will be my current? My current will be infinite. So sometimes we connect the resistor to limit the current. So why we have to limit the current? There can be some protection issues. Say this uh, resistor cannot like allow current more than say few amperes, then the device will get damaged. So in order to protect the devices, you should ensure that current is limited, and sometimes resistor is connected in series to limit the current sometimes, but not always, but that is one of the application. Okay, sir. Yeah, so V is equals to IR, which you know as Ohm's law. Okay, so just quickly, if you draw the VI characteristics or IV characteristics, V is equals to IR. So it's a straight line passing through the origin. And what is the slope? Slope is I by V, which is 1 by R. Inverse of resistance. R is resistance, which is also called as conductance, and it is represented by the letter G. And what is a capacitor? Capacitor is something like this. Say plus minus V, and the current is entering. So current, whichever plate or the terminal the current is entering, that plate will have a positive sign. Say this is I and the capacitance is C. So how these are related? I is equals to C dV by dt. And V is integral. So let me use a different color. V is 1 by C integral I dt. So as there is integral, it needs information from below. Say for time t, we need information from minus infinity. So it has some memory. And here there is no memory. So that's why this is memoryless. This is memoryless because the voltage depends upon the instantaneous current because V is equals to IR directly. But here the voltage depends on the past values of the current. So it has some memory. So this is having some memory element because it depends upon the earlier values as well. So now if you go to inductor, we'll represent it something like this. Again, say the current plus minus V and the current is entering I, L. So here it is having the relation V is equals to L into di by dt. And if you again see, I is equals to 1 by L integral V dt. So if at time t we need to have from minus infinity to t. So now it becomes again memory elements. So these two are memory elements because the voltage of a capacitor depends upon the past values of inductor. Similarly, the voltage of the current of the inductor depends upon the past values of voltages. So if you see, it is analogous. Voltage in the capacitor, it is similar to current in the inductor. Current in the capacitor, it is similar to voltage in the capacitor, something like that. It is also having some memory. So these two are elements with the memory, and resistor is a memoryless element because it depends upon the instantaneous values. Here it depends upon the past values as well. So that's why these have memory, and the other two doesn't have memory. So now, if you have any doubts, you can ask before we go into mutual inductor. Any doubts? Okay. Then we'll go to the mutual inductor, which is four terminal device, as I have pointed out earlier. I hope I'm audible.
Yes, sir.
Okay. Sir, repeat please. Okay. Mutual inductor, I'll just repeat. So, resistor, capacitor, inductor, these are the circuit elements. Sir, how we can practically compare inductor and capacitor? Okay, that also I'll tell you. Resistor is represented by like this, and this are capacitor and inductor. Here we have V equals to IR, which is also called as Ohm's law, and this is the IV characteristics. In the case of capacitor, IV are dependent using this expression I equal to C dV by dt. From this, you can get the V expression. Here, inductor V is equals to L dI by dt, and the current is obtained by this expression. This is memoryless because voltage and current depends upon the instantaneous values of the voltage and currents. Here, the voltage of the capacitor depends upon the past values of the current, which is why it has some memory because it depends upon the previous value also. Here also, the current of the inductor depends upon the past values of the voltages. So that's why it has a memory. If you see here, for capacitor, whatever is voltage, for inductor, it is the current. And for capacitor, whatever is the current, for the inductor, it is the voltage. So you can see this correlation between these two. And in practically, capacitor is used as a voltage source. So whatever voltage source that we have considered, it can be considered as a large capacitor. So this can also be represented by using a large capacitor. So capacitor voltage should be constant or voltage should be continuous. If voltage is not continuous, I is what differential of dV by dt. If there is discontinuity in the voltage, current will be infinite. So that's why capacitor voltage will be continuous. Voltage cannot change immediately. So that's why people use large capacitor as a voltage source. How capacitor is considered as a voltage source? Okay, that also I'll tell you. And inductor is considered as a current source. So basically, I is equals to C dV by dt, right? So I is equals to C into dV by dt. Say voltage is not continuous. What will happen if voltage is not continuous? If voltage is not continuous, then what will happen? The differential of voltage will be infinite, right? So I will be tending to infinite. So in a capacitor, voltage cannot change instantaneously. So at this moment, it cannot be 2 volt, and in the next moment, it cannot be 5 volt. So it will change smoothly. So continuously, the voltage has to change. So now, if I consider one large capacitor bank, the ability of the capacitor to change immediately will reduce. So if I am adding more and more and more and more capacitors, then the voltage will be more stable. So if I want to have a voltage source, I will consider a large capacitor. Similarly, so it is analogous. Similarly, in the inductor, V is equals to L di by dt. Whatever is the voltage here, it is current in the other one. So here what happens if voltage, meaning here capacitor voltage, here capacitor voltage, and here inductor current. If the inductor current is not continuous, then what will happen? Then voltage will become infinite. So current has to be continuous. And if I consider very large inductor, then current will not change instantaneously and it will almost more or less remain same. So that's why I have said large inductor can be considered as a current source. So these are the applications of that voltage and inductor. So sorry, capacitor and inductor. Yes. So now we'll go back to mutual inductor. We'll quickly go through this before we go into the problem solving session. Yeah. So mutual inductor meaning we have two inductors and they are mutually coupled. So the flux produced by the current in the coil 1 will also produce current in the coil 2, and similarly the flux produced by the current in the coil 2 will also produce some current in the coil 1. So that's why there is some flux that is common for both of these coils, and the current in one coil is affecting the current in the other coil, something like that. So they are mutually coupled. So the mutual inductance is represented by M, and the self inductance are represented by L1 and L2. And here we have voltages plus minus V1, and here we have voltage plus minus V2. So there is something called dot convention, which is very, very important. Okay. And say the current is I1 here and the current is I2 here. So why the dot is important? Dot is important for the polarity. Dot is important for the to know the polarity of the voltage. Okay. So depending upon the dot, whether the current is entering the dot or current is leaving the dot, depending upon that, the voltage polarity is decided. So we can have two or three cases. In one case, current is entering the dot. In the other case, one current is entering the dot and one current is leaving the dot. In the third case, both the currents are leaving the dot. If the currents are leaving the dot or if the currents are entering the dot, both are the same. But uh, basically, we'll have two cases. So yeah, so I'll consider in the new page these cases. So here we have case one. What do I mean by case one? I'll show you. Case one. So basically, in order to get the voltage expression, we need to know the polarity. So we need to know how or what is the voltage of the polarity because of the current in the second coil or the first coil. So let us consider this and keep it here. Okay. And then erase this. So if this is the case, say currents are entering the dot. Currents, both the currents are entering the dot. So now what happens is the voltage induced in the coil 1 because of the current in the coil 2 will have the same polarity because of the voltage induced by the I1. So what I mean to say is I1 will induce some voltage and that will have some polarity. And because of the I2 and this mutual inductance, there will be some voltage induced by this current in coil 1. Both will have same polarity. In simple terms, polarity means the sign convention of the voltage. So basically, this can be plus, minus, or this can be minus and plus. So how will I know which is plus and which is minus? So that is called polarity, which means the positive terminal. So if current is entering one terminal of the inductor, that will have plus. So whichever terminal the current is entering, that terminal will have positive polarity. So that is called polarity, positive or negative sign or charge, which is positive sign, which is negative sign, that is called polarity. So if the currents are entering the dot, then V1 will be positive. So L1 into di1 by dt, which is because of the self inductance, and another term is because of the mutual inductance. So which is caused by the second coil. Because current is entering the dots in both the case, this will be plus sign. Okay. Similarly, if I consider V2, which is L2 into di2 by dt, because for coil 2 it is the self inductance of coil 2 and current in coil 2, plus M into di1 by dt. So if the current is entering the dots, then this will be positive. So let me just consider this box. Okay. So now what is the case 2? So I'll just copy paste to save some time, and then I'll modify, and then I'll highlight what are the differences so that you can understand what are the difference. Okay. So this is case 2. So we have case 2. So in case 2, what is happening? One current is entering the dot, one current is leaving the dot. Okay. So case 2, current is entering the dot. One current is one current is entering the dot, and the other one is leaving the dot. Okay. So let us change the direction. So I2 is leaving the dot, right? Okay. So I2 direction is this. Got it? So if I2, so same I2 will be coming here and same I1 will be going here. So I have told whichever terminal current is entering the inductor, that terminal will be positive. So in this case, this will not be positive and this will not be negative. In this case, this will be positive and this will be negative because current is entering this terminal. So this is the polarity. So this you have to keep this in mind. And also, because in one case the current is entering the dot and the other case it is leaving the dot, instead of plus sign here, we'll have minus sign. Okay. Similarly here, instead of plus, we'll have minus. And this is very, very critical that you should keep in mind. Okay. I'll just quickly summarize this again. Maybe you might have some confusion. So mutual inductor, we have four terminals, and current in one coil influences the voltage in the other coil and vice versa. So before getting into deep like why it is happening, that we will get into it later, but for the timing we should understand the polarity means which sign is positive, which sign is the negative, so the dot will help. First of all, if the current is entering one terminal of the inductor, that will have positive. So in the case one, current is entering this terminal, current is entering this terminal, so this is plus, this is minus, this is plus, this is minus, so that will be the first thing that we should do. So after that, you have to check whether the current is entering the dot or current is leaving the dot in either of the cases. Here it is entering, here also it is entering. So this will be plus plus. Now we'll come here. Here the current is entering, here the current is entering. So here this is plus, here this is plus. So first part is done. Now we have to see whether the current is entering the dot or leaving the dot. Here it is entering, here it is leaving. So one it is entering, another it is leaving. So here it is minus and here also it is minus. So is this part clear, or should I explain again? Anyone? Hello.
Clear, sir.
Yes. So other people, is it clear, or you have any query? Clear. Okay. If you have any doubt, you can ask. Please don't hesitate. I'll explain. Clear. Okay. And this polarity is very important, and don't try to confuse yourself at this point of time. Sir, what if the dots are present at the bottom of the inductors and that too on the outside? Are they same? Yes. If the dots are here, then also same. First, you have to see whether which terminal the current is entering. That terminal will have positive terminal. So that is the first point that you should do. And then you have to see whether the current is entering the dot or whether the current is leaving the dot. So that part you should also understand. So no matter the location of the dot, the logic will remain same. Accordingly, you will get this plus and minus sign. Say even if these dots are here and here, then first part is which terminal the current is entering. Current is entering here, current is entering here. So plus and minus, plus and minus. And if say both the dots are here and here, then still current is entering in one and current is leaving the dot in the other. So the same logic, the same case is applicable. So this becomes minus and this also becomes minus. So that part you should keep in mind, and it is very critical. So is that part clear? Hello. Okay, sir, clear. Yeah. So this polarity you'll understand better when we solve few problems. Then you can have a better understanding. Again, there is less than a minute. So if this meeting and kindly join
Hello,
back.
sir.
Yes.
Sir, can you explain me that you have changed the direction of the current in coil 1 on coil 2 only?
Yes.
So the sign change should be in the coil 2 only. Why had you changed the sign of equation 1, sir? Like
Yes. Yes.
V1
Okay.
equals to L1 di by d2 plus M di 2 by d2
Yes.
should
Yes.
be
Yes.
there.
I'll explain. So
You have changed
first
it
of
to
all,
minus.
So first of all, there is less than a minute. So if this meeting and kindly join back. Now I'll continue. Maybe the meeting will end in between. We'll join back and continue the discussion. So basically, this dot polarity, what it means or what it shows is how the mutual inductance term is getting affected, how the polarity of the mutual inductance is getting affected. So in the subsequent classes, I'll explain how this dot convention is coming and who decides this dot and how this minus sign is coming exactly in detail I'll explain, but as this being week one, which is only some introduction, we'll not go into the details, but I promise that I'll explain in the upcoming classes. So we have, sir, can you provide this meeting in the recording? Yes. So this meeting will be provided in the recording format, and I have also mentioned in the top of this chart my three important links, and I'll just again copy paste and then paste it so that it will be useful. It will be easy for you to access. Okay. So I'm sending again three messages in the chat. So where I have given YouTube channel link and where I'll be uploading these three, I mean, this recorded video. Okay. So basically what this dots and whoever has asked in the earlier session, uh, what this dot convention is about. So basically dot convention decides the polarity of the, sorry. Okay, someone is unmuted. Can you please mute yourself? Okay. So this dot convention depends or decides the polarity of this minus sign, right? So minus sign of these two is the mutual inductance part. Okay. Sir, if we can connect capacitor to the inductor, how the polarity will affect the flow? So capacitor will not affect the flow of this polarity. So the polarity comes from the inductor itself. So once the inductor is selected, the polarity will be selected. So we'll not get into the details because that will confuse you now. But for the time being, you just understand that this dot convention is to get or know the polarity of the mutual inductance part. So if the dot convention say is like this, so if the currents are entering the dot, it means the current in the coil 1 will induce a positive voltage in the coil 2. So that's why we are having plus and plus. Similarly, the current is entering here and the current is also entering here. It means they are connected in such a way such that the current in the coil 2 will induce a positive voltage in the coil 1. So here the like the effect is positive. So now if we come back here, one case it is entering, one case it is leaving. Or if you consider here it is leaving, here it is entering. So it is opposite. So the current in the coil 2 will induce a negative voltage in the coil 1. Similarly, the current in the coil 1 will induce a negative voltage in the coil 2. This we can understand if you think from a flux point of view, but we are not going in that direction, at least in this week. In the upcoming weeks, maybe we can go through that. Maybe I'll dedicate some time, as today we are running out of time. I'll not go into that, and also it will confuse you more. So for the time being, you just remember this polarities, how plus is coming, how minus is coming, but why it is coming, that we'll discuss in the upcoming weeks. So is that clear? Even if you have few queries, it is okay. You just keep that in mind. I'll explain it from the transformer view. So in that, I'll explain how to decide this polarity and how the current directions will affect this mutual inductance term. So that also we'll discuss. Okay. So basically, this polarity is to understand the so this dot convention is to understand the polarity of the voltage, polarity of the induced voltage. So that will help us whether it is positive or whether it is negative. But again, we'll come back to this concept, and I know this it is somewhat confusing. But once we actually see the windings and everything, it will be more clear to you. But at least for this week, we are not going there. It will confuse you more. Okay. So we'll start with the problem solving session. So I'll solve one assignment. So this week, I had to spend more time because I had to introduce myself and explain you about this problem solving session. So, but from the next week, we'll try to wrap up our summary session a little bit faster so that we'll have somewhat more time and we can spend more time in the assignment solving. So we'll start with the assignment one. So let me just take this screenshot. So they are saying determine the current I1 in the figure below. So can you tell which Kirchhoff's law we have to apply to solve this problem?
KCL.
KCL, yes. Yes, yes, right. And also you know that the direction of the current is opposite to the direction of electrons, right? Uh, so that is the convention that we take. So if current is flowing from terminal A to B, it means the electrons are flowing from B to A. So here they have given the direction of the electrons, not the current. Okay, so this is problem solving session. So let me just write assignment one, which means week one. Okay, and this is our problem one. So this is the direction of the electrons, which means this is the direction of the current I. So first is how to calculate I. We know that the definition of I is the amount of charge flowing per second, which means Q by T. So charge by time is the value of current. You know this definition, right? And they have given 62.5 billion electrons. 62.5 billion means 10 to the power 9. And electron means, you know the charge, right? What is the charge of the electron? 1.6 into 10 to the power minus 19, right? Agree? Hello?
Yes, sir.
Yes, sir.
So 62.5 billion electrons, 10 to the power plus 9 into charge of each electron is 1.6 into 10 to the power minus 19 coulomb by in what time? 1 nanosecond, which is 10 to the power minus 9. So can you please calculate and tell me what is the value of this? What is the value of I?
10.
Okay. Are others getting the same value? Hello? Is everyone getting 10 amperes? Hello? Okay. Just check if the current is 10 amperes or not and just let me know. So applying KCL. KCL is what? Sum of the currents entering, which is, sir, can you tell this problem again? Okay, okay. So basically they have given that 62.5 billion electrons are flowing in this direction. What is the value of the current in amperes? Okay. They have given the direction of current I1 as well. So we know that uh, current direction is opposite to the direction of the electrons, right? So they have given the current electron direction is from left to right, which means the current direction is from right to left. So that we have realized. And what is the value of current? It is Q by T. Q is the charge. So how much is the charge? We know the charge of one electron is 1.6 into 10 to the power minus 19, and such 62.5 billion electrons are flowing in 1 nanosecond. So this is the overall charge and this is the time. So from this we got I equal to 10 ampere. Now I have to apply KCL. KCL says the current that is entering, which is 2 plus 1, is equals to the current that is leaving, which is I plus I1, which is 10 plus I1. So can you tell me what is the value of I1?
-7.
Minus 7. So now can you tell me what is the significance of this minus here? What is the meaning of this minus? So
Sir, it's leaving the node, sir.
yes, yes,
The
yes,
direction of current is opposite to the assumed direction.
yes. Very good. So when we try to solve any problems, we try to assume some current I1, and you are free to assume any direction of the current. And once you solve, either you get a positive value or a negative value. If you get a positive value, means the assumption of the direction of the current is correct. If it is negative, it means the direction of the current is opposite to your assumption. So here yes, current is leaving in the opposite direction. Here, the current is going down, but I got negative, meaning the current is actually going up. But you should be very clear how they have asked. Here, they have asked the value of I1, and the value of I1 is -7. If you enter 7, you will not get marks, and this is very, very important, and you have to be very clear. If you enter 7 and say that the value is same, but I have considered different direction, you will not get marks, because direction is also important and the value is also important. So both direction and magnitude are important. So please be careful. If they have asked what is the magnitude of I1, then it becomes 7. If they have asked what is the value of I1, then you should also add this minus sign. Okay. Is that clear?
Yes, sir.
Okay. So now we'll solve this current. Here you just go through. They are saying what is the voltage of Vx, and V1 can be obtained from this. So here which KC, whether KCL or KVL needs to be applied? Anyone?
KVL.
KVL. Okay.
KVL.
So someone has asked, sir, can you please explain? I'll just explain the problem one again. So problem one, they are asking the value of I1, and they have given the electrons are flowing in this direction. So if the electrons are flowing in this direction, current is actually in this direction, and I is equals to Q by T. So I have calculated Q, and T is also given. Then I got I. Then I have applied KCL, and applying KCL gave me I1, which is -7, and I have to retain the sign because they have asked what is the value of I1. So I have to use that -7, and I have to write in the box what is the I1. So first, before applying KVL here, you are right. You have to calculate what is the value of V1. So can you tell me what is the value of V1? Now I will apply KVL here. Okay. So I'll apply KVL here. Sorry. So first apply KVL. So current is flowing like this, which means it is plus here, minus here. So I'll traverse in this loop. So can anyone tell me V1? Yeah, someone said -4, right? So I'll get plus V1, and what is this? Again plus, right? So from here to here I went, and from here to here I have to come. So if there is increment in the potential, it will be positive. If there is decrement in the potential, it is negative. So from here to here, it is increment in the potential. From here to here also, it is increment in the potential. So plus V1, and then plus I into R, which is 2 milli into 2 kilo. The summation will be 0, which is what we have learnt. So V1 is -4 volt. So basically, again, what it means? It means the polarity of the voltage source that has been assumed is opposite because we got a minus sign. So is this part clear how we are getting V1 equal to minus 4 volt? Okay. So if you have doubts, you can ask. So we have applied KVL here, and then we got the value. So I'll explain again. They have given this is positive terminal, this is minus terminal, and the current is flowing. We know whichever terminal the current enters, that will become positive. So we know the polarity of this resistor. This will be positive and this will be negative. Now I have to apply KVL, which means I have to traverse through this loop, and we know the convention. If I am going to a higher potential, it means the sign will be plus. So I have started from here. So basically, I have gone in this direction. I have gone in this direction. So from here to here, we are going to a higher potential because V1 is assumed in that way. So it is plus V1. And from here to here, again, we are going to a higher potential. And what is the value of that voltage? It is I into R. I is given, R is given. So plus V1 plus this. So V1 is minus 4 volt. Basically, what it says is V1's polarity is plus here and minus here. But that is okay. Still, we can consider whatever polarity they have given and we'll consider the minus 4 instead of 4. So is that part clear? Whoever has asked this query.
Yes, sir.
Okay, okay.
Clear,
So
sir.
yeah. Now once we got V1, then we'll apply KVL here. Okay. So again we have to do the same thing. We'll start with one point and I'll start with this point and then I'll go in this direction. Okay. So first there is increment in the voltage. So is it plus 2 or minus 2? Anyone?
Sir, plus 2, sir.
Yes, plus 2 then plus or minus V1.
Minus V1.
Why minus?
Minus.
Plus V1.
Yes.
Plus
So for
V1.
so
Yeah,
forget about
minus 7, sir.
yes, forget
He is
about
working on.
whether V1 is positive or negative. According to this convention, I don't know whether V1 is positive or negative, but according to this convention, this is at a higher potential. So it will be plus V1. Now we will substitute that V1 is minus 4. So you should not bring the polarity here. So because they have given this is minus and this is plus, which is same as this. So you should consider the same polarity. And once you are substituting the value of V1, then you will substitute minus 4. Okay. Similarly, from here to here, we are going to a lower potential. So it is minus 1 volt. And again from here to here, is it plus Vx or minus
Plus
Vx?
Vx.
Plus
Plus
Vx.
Vx.
Minus.
Not minus plus Vx because we are going to a higher potential. So you have to use the polarity that they have given. Now whether Vx is positive or Vx is negative, that's a secondary. So now we will get Vx is equals to V minus V1 minus 1, which is minus V1 is how much? 4 and minus 1, which is 3 volt. So you have to be very careful. So first you have to proceed with the polarity they have given and then you have to substitute. So is this part clear?
Yes, sir.
Yes, sir.
Okay.
Yes,
Because
sir.
uh, they have not given the value of V1. First we have solved for V1 and we got V1 is minus 4 volt. But we have to proceed with the polarity they have given and then substitute V1 as minus 4. So we have applied KVL here to get V1 and then we have applied KVL here to get the relation between Vx and V1. And then once I get the relation between Vx and V1, then I have substituted V1 is minus 4. So then I got Vx is equals to 3 volt. So which is what also they have given 3 volt. Now, problem 3 is very simple. Can you solve? They have given IV characteristics of resistor and they are asking what is the value of resistor R. Can someone tell? This is a simple problem. I hope you will be able to solve.
Slope of the line.
That 20 kilo ohm.
20 kilo ohm. Okay, let us solve. We know that resistor R is voltage, instantaneous voltage by instantaneous current. So what is the instantaneous voltage here? Instantaneous voltage is 3 volt or minus 3 volt. And the current is minus 150 microampere. So it becomes 10 to the power 6 by 50. I can also write it as 100 into 10 to the power 4 by 50. So this is 2 times 2 into 10 to the power 4. So resistor is 20 kilo ohm. So this is very straightforward. So you understood how we have solved. We know the Ohm's law. V equals to IR, and they have given V and I. So we know that R equals to V by I. And you know that resistor cannot be negative. So if the voltage is negative, current has to be negative. If the voltage is positive, current has to be positive. So that's why it will be in quadrant 1 and quadrant 3. Here they have applied a negative voltage, which means the current will also be negative. It means the opposite direction basically. So is this part clear?
Yes, sir.
Okay. If you have doubt, please ask. So basically, here we have applied KCL, and here we have applied KVL. Here we have applied Ohm's law. So you just have to see what they have asked, and which law we have to apply, and then accordingly we have to do. So in this figure, now they have given a mutual inductance. Okay. And they have asked the voltage at t equals to 3 microsecond. Okay. So first of all, irrespective of what is asked in the question, if they gave you some mutual inductance or any related, first you have to draw the expression. So first we'll identify step by step. So I'll ask you. So I1 is given, I2 is not given. So we are free to assume the direction of I2, right? Because I2 is not given. And can you tell me what will be the value of I2?
0.
0. Why? Because it is open circuited. And we have to obey KCL. So current entering should be equal to current leaving. There is no current entering, so current leaving will also be 0. So I2 will be 0. So that is our first point. Okay. Now I will assume the direction of current in any way. So for my ease, I will assume the current is flowing like this. So now you tell me whether the current is entering the dots in both the cases, or which case? Is it case 1 or case 2? Case 1 being current is entering the dots in both the cases. Case 2 being one current is entering the dot and one current is leaving the dot. So it comes under which case?
Second case.
Uh, Can you check? This is I1 and this is I2.
Case 1.
Case 1, because current is entering the dot in both the cases. So it comes under case 1. And we know that in case 1, it is plus M, right? So I'll just go to the top and I'll use the same. So I can copy paste this and I can use it here. So we know that V1 is equals to L1 into di1 by dt and V2. Now comes the critical part. So first step, we know that whichever terminal the current is entering, that is positive. So here current is entering this terminal. So this is positive. Whereas in this case, current is entering this terminal. So this is plus, this is minus. Okay. And after that, we know that current is entering the dot. So these two will be plus and plus. So is that part clear?
Yes, sir.
Okay. Now we'll go. Now first we have written these. Sir, can you please explain how you have considered I2? If you see, there is no path for the current. So current entering should be equal to current leaving, right? So if there is no path for the current, current cannot go anywhere. So there should not be any current. Then only it will obey KCL, right? So if you consider this point, the point is like this. So here no current is entering, I equals to 0. So here also current should also be 0, because I have conduct, I mean, I have a voltage source, I have a resistor. Only if I connect the voltage source to the resistor, current will flow, right? If I don't connect, current will not flow, because there is no path for the current. So current should have a path to flow. If there is no path, or if there is something open in the loop, current will not flow. So that's why the current is 0. Then only the KCL will obey. Sir, how did you determine the direction of the current in the secondary inductor? So now they have not given the current, and also I know that current value is 0. We are free to assume the direction of the current, because anyway it is 0, it doesn't matter of the direction. But for my ease, I have considered the current is entering the dot, because I know in that case there is no this minus business, and everything is straightforward, plus and plus. So that's why I have assumed this current direction. But you are free to assume in the other direction as well, and still you can solve for it. Got it? But once you assume the current direction, that will fix the polarity of the V2. Say, very good question that you have asked. Say now, instead of like this, I have assumed the current like this, which means current is entering like this. So in that case, this becomes plus and this becomes minus. So once you assume the current, you have to follow all the polarity rules that you are considering. So first I have assumed the current, then I have assumed that first of all, I have assumed the current is entering the dot, which means whichever terminal the current is entering, that will become positive. So that's why I have considered plus and minus V2 like this. But if you are considering the current in this direction, then this will become plus. So these rules you have to strictly follow. So irrespective of the direction of the current, you will end up getting the same answer, but you should follow all the rules properly. You should not violate any of these rules. So one person has asked, so what is the I1 in the graph given? Okay, so this has some information. We'll come back to it slowly. So in the question, they have asked what is the voltage V1 at t equals to 3 seconds. So what is the voltage V1 at t equals to 3 seconds? So in the question, they have asked V1 at t equals to 3 seconds. So what is this value? So in order to know the V1, which equation I will use? I will use this equation. Okay. V1 equal to L1 di1 by dt plus M into di2 by dt. However, I2 is 0. So I will have V1 equals to L1 into di1 by dt, right? So my V1 is equals to L1 into di1 by dt. They have given L1, but have they given di1 by dt? No, they have not given di1 by dt directly, but they have given I1. But from that I1, I can calculate di1 by dt. What is di1 by dt? Basically, the slope of the current, right? So what is the slope at this instant at t equal to 3 seconds? I mean 3 micro. Can anyone tell me? Anyone?
Zero.
How is it slope?
-1.
How much?
-1.
Okay, and how did you get it?
Dy di divided by dt. Change in the
Yes.
current divided by, I have considered 2 points at t is equal to 1 and t is equal to 3. Get
Okay.
what is the change in the current, get what is the change in the time, divided to get this.
Yes, yes, good. So what she basically did is considered one point here and another point here, and the slope of the line is y2 minus y1 by x2 minus x1. So 2 minus 0, 2 milli. So 2 minus 0 milli, right? 10 to the power minus 3 amperes by 1 minus 3 microsecond. 1 minus 3 into 10 to the power minus 6. So you will get 2 into 10 to the power minus 3 by 2 minus 2 into 10 to the power minus 6. So the slope is 10 to the power 3 minus. Okay. Now I have to substitute that here. So V1 is equals to L1. L1 is how much? L1 is 4 millihenry. So 4 milli into di1 by dt, which is minus 10 to the power 3. So now doing this, we will get V1 equal to minus 4 volt. Got it? How we are getting minus 4 volt?
Yes.
Sir, why we are considering 1 minus 3 in the x-axis? Yes. So first we have to consider x2 comma. So let us consider the points, then things will be clear. So this is my x2 comma y2. This is my x1 comma y1. I know that slope m is y2 minus y1 by x2 minus x1. So what is my y2? 2 milli. And what is my y1? 0. So 2 minus 0. And what is my x2? It is 1 micro. And what is my x1? It is 3 micro. So that's why that minus is coming. And also you can see that the slope is negative because with respect to time it is decreasing. It means the slope is negative. And also you can also say in a different way that the angle is more than 90 degrees. So the slope is tan theta and it is negative. So how we have calculated the slope? We have considered 2 points on this line and we have used this slope formula m equal to y2 minus y1 by x2 minus x1. And that's how we got the expression of the slope. Sir, should we select the slope which is connected at 3 seconds, sir? Yes. So we also know that if there is a straight line, the slope is same, right? At any point, the slope is same. So if you consider this point and calculate the slope, it will be same at this point also. So you are free to consider any line on that line. So I have considered this point and this point. You can also consider this point and this point, this point and this point. Any point you are free to consider only on that line, not on the other line. So here we have considered these 2 points and then calculated the slope. And from the polarity that we have learned, we first wrote the equations, and then using one of the equation, we have calculated the voltage. So is that clear? Is that part clear?
Yes.
Sir, if the slope is started from 0 in the x-axis, then should we consider 0 to 3? Yes. So if they asked the slope at this point, then you have to consider this line. Similarly, if they have asked at this point, then you have to consider this line. So you have to be sure at what time they have asked the voltage. So that's why they have explicitly mentioned the time, because voltage is dependent on the slope of the current. If the slope changes, voltage will also change. So that's why they have asked. So what is the value of x to the power 2? Sorry, I'm not able to understand what do you mean by x to the power 2? What is x here?
Why we put x2 equals to 3?
Okay. So I have considered this as x2 comma y2, and this as x1 comma y1. So y2 is what? Y2 is 2 milli. Let me write, then it will be clear. So this is 2 milli, and y1 is 0 milli, and x2 is this, which is time. This is 1 micro, and x1 is 3 micro. So that's why we got 2 minus 0 into milli by 1 minus 3 into micro. Is that clear?
Okay.
Okay. Okay, we will be getting around, we'll be getting time to solve maybe one more question. So we'll see which question is good. This question, yeah, we can solve this question also. This is regarding capacitor. So you just read out the question. They have given a capacitor with inductors, sorry, with the current sources, and they're asking what is the voltage VC at time t equal to 6 microsecond. Okay, so this is also simple. It might look a little bit complicated. So if you go through with the concept of the capacitor, then it will be very simple and straightforward. So first we have to always start with the equation. What do we know about the capacitor voltage and current relations? So we'll start from that point. So this is question 4. So first, forget about the question. I know that IC is equals to C into dVC by dt. VC is the current in capacitor, VC is the voltage in the capacitor. So now I know they are asking VC, right? So VC of t is equals to 1 by C into integral of IC dt. You agree, right? True?
Yes, sir.
Yeah. So in this, now we will come back to the question. Say this is IC. Can you tell me what is the value of IC in terms of I1 and I2?
I1 plus I2.
Yes. So IC is basically what? I1 plus I2. Now you substitute this in this expression. Okay. Now what we'll be getting? We'll be getting VC of t is equals to 1 by C under bracket integral I1 dt plus integral I2 dt. Okay. Now we know that integration is nothing but area under the curve, right? So they have asked time till 6 microsecond, right? So now what we have to do is, this is 6 microsecond, right? So this is 6 microsecond. This is also 6 microsecond. So what we have to do is, we have to add the area of this curve. Got it? This area and this area also. Got it? But you should realize that area will have a positive sign as well as negative sign depending upon whether it is above the x-axis or below the x-axis. Agree?
Yes, sir.
Yes, sir.
Okay, someone has asked the link. He has asked me to share the link again. Just a minute, I'll share. Okay, I'm sending the message again. Sorry. Yeah, I have sent you. Just please check. Someone has asked, please explain the final step. So in the previous question, I2 is 0, so L1 into di1 by dt plus this part will be 0, and di1 by dt is the slope at this time period t. So I have calculated the slope and then I have substituted to get the voltage. So now in this question, we have to find the area under the curve. So let me like solve the area under the curve. So can you tell me what will be the area of this curve? Like this one?
Sir, 10
10, right? 5 into 2. Good. So this is plus 10. And the area of this curve?
minus 5,
Minus 5. And the area of this curve?
10
And the area of this curve?
minus 5,
Okay. So now what is the overall summation?
10.
A1 is 10. Okay, that is area. Got it? So now area, what is the units? Milli into micro, right? I into T, right? Integral I dt. So I into T, which is milli into micro. So we have 10 nano. Got it? Okay. Now, if you see here, we have to break down into small triangles also. Got it? Fine. In the second problem. Hello. To
Yes,
find the
sir.
area. Yes.
It will be 10, sir. The whole first part will be 10
Okay. We'll come
because
back.
two squares.
Yes. So now I know that some of the area is positive, some of the area is negative. So first I'll cancel out which one is positive and
आपने
negative
मेरी
have the
लिंक्डइन
same.
प्रोफाइल खोली क्या?
Sorry, can you please mute yourself? So this area and this area are same but have negative sign, right? Agree?
खा लो अब खा लो.
Agree?
Yes, sir.
Yeah. So these two will get cancelled. Similarly, this area and this area will get cancelled because they have same magnitude but different sign. Agree?
Yes, sir.
Yeah. Now, what is the area of this and what is the area of this?
5, 2.5.
5, 2.5. So this is 5, this is 2.5. Agree? So A2
Yes, sir.
is how much? 7.59.
7.5.
So now we'll substitute this here. So this becomes A1 and this becomes A2, right? Again, there is less than a minute if this meeting and kindly join back. So we might solve another one last problem. After this, we'll solve one more problem. So C is what? 20 nano and A1 plus A2 is what? 17.5 nano. So now can you tell me what is the value of VC? Okay, I'll explain again. Let this meeting end, I'll explain again. Can someone calculate and tell me what is the value of VCT?
Sir,
Yes.
it will be 17.5 milli, right, sir?
No, no.
because 10 power minus 3 by 10 power minus 6.
No. Okay. So yeah, again we got a question here. A time varying current is passing through a surface with a cross section area of this. What is the amount of charge has flown through the surface in the 10 second? With respect to the given problem, should we take limits as 0 to 10 or 9 to 10 or 10 to 11 for integration? Okay. So in your question, they have given I and they have given A. So you know that I is what? The amount of charge that is sorry, they have given current and they have given area. So what amount of charge that is flown through the surface in that 10th second? So now can you tell me what is the relation between the charge, area and current and time? Q is equals to I into T, right? Hello. Okay, I'll explain this problem again, but how do we determine the limits for similar problems like this, sir? Are there any thumb rules? So basically, first you have to write the relation between the quantities that they have given and the quantities that they have asked. So one of the student has asked what is the amount of charge that has flown through the surface in the 10th second. So now you have to see Q is equals to I into T, right? So the charge that is flown at that particular instant time T is equals to Q is equals to I into T, right? So now I is a function of T. Okay. So let me just write that expression. Just a minute. So Q is equals to I into T. Or you can say, so if they have asked the total charge that has flowed till this time, then you have to integrate. But if they have asked at that moment, then you have to substitute the instantaneous values of the Q. So in the question that you have asked what is the charge that has flown in the 10th second. So it is at that instant of 10th second, right? So that's why you have to just substitute the instantaneous values. So current is a function of time, so you substitute time there, and then you substitute the instantaneous value. But if they ask something in the duration, which is like a area, then you have to do the integration. So if they ask at the instantaneous, then you have to do the instantaneous value. But if they have asked something like integration, then you have to do the integration. So first you have to always write this expression. So here we have done Vc of t is equals to 1 by c into integral ic dt, right? And there is some previous value of this as well. So now in that question also you can do something like this. We know I is equals to dq by dt. So q is equals to integral I dt. So now q at time t is equals to, say, whatever t naught, I'm generalizing, then you have to do integral I dt from minus infinity to this time t. So first you have to write the equation, then you have to go to the question what they have asked. So they have given t square plus 5t plus 6 and in the 10th second. So t square plus 5t plus 6. So as time is a positive quantity, it cannot be negative. So you have to integrate from 0 to whatever t naught they have given, t square plus 5t plus 6 into dt. So this you have to do. So first always write the expression relation and then try to get into a mathematical form and then you see what they have done. So q of t is equals to integral. So basically what we'll be getting is q of t, q at time t is equals to integral 0 to t I dt, right? So this is the expression. So now you check at what instant they're asking and then substitute that value of t and then integrate it to get that uh, whatever they have asked. So let me just take a screenshot and then keep it here so that people who are unable to see that chat, they can also get. So this is the question that someone has asked, and this is the solution for the same. Okay. So is that clear? I hope it is clear. Sir, can we find instantaneous value by the integration? Yes. So now if you see, q is an integral of I dt. So the q value at instant time t depends upon the current value in the past. So which is what we have actually started with in the beginning. So there are some elements which has memory. So the instantaneous value of the voltage of a capacitor depends on the past values of the current. It does not mean that this value like is not instantaneous, because this is a memory element. The instantaneous value of the voltage depends upon the past value of current. In the case of resistor, it is the instantaneous value of the current. But in these elements which has memory, even if you want the instantaneous value at that particular point, say here they have asked voltage at t equals to 6, but we know that voltage is dependent on the past value of current. So that's why we have calculated the area under the curve. Similarly here, charge is the integration of the current with respect to time, and current is also changing. So current will have a such graph. So the area under the graph until time t is equals to 10 will give the charge. So it is not that we are integrating, but the instantaneous value of the charge depends upon the past value of the current. So it has a memory. So that's why uh, it is coming. It is not that it is not instantaneous. Is it clear? As it is having a memory, it depends upon the past values also. Yes. So that's why always don't start with the question. So I know that they have given current. I know that they have given time. I know that they are asking charge. So first I will write the equation. First I will get the expression. Now I will start substituting the data from the question. If you start with the question, you will get confused. So the basic is very simple. Q is equal to integral I dt. Now what is the I and what is the time t that they are asking? Then it will become simple. If you start from thinking from the question point of view, you will get confused. Okay. Now we'll get another time to solve
Sir,
another one question probably. Yeah.
sir, in that question they asked at the 10th second, not from whole 10 second. So it will be at 10 minus 9, like that only, sir.
No,
Or
no,
it
no.
will be 0 to 10.
See, again. So what does this expression say? So I'll correlate with this. So I at a time instant t is equals to C into the slope of the voltage at that time instant t. Okay. So this is very straightforward, easy. Now I voltage of the capacitor at that time instant t is 1 by C into integral of I dt till that time t. So the area under the curve of I till the time instant t divided by the capacitance gives the voltage at the time instant t. Because it has memory, it needs the area under the curve until that point to get the instantaneous voltage. Because it has a memory, it is always area under the curve. So whatever problem that we have solved here, we are trying to find the VC at the time instant t, but it is dependent on the area under the curve of the currents. Because it has memory, it is dependent on the past values of the current, not the voltage, right? Past values of the current. So area under the curve will give the voltage at that instant VC of t. Now if I ask what is the voltage at 5 microsecond, then I have to calculate the area under the curve until this point only. Because it is a memory element, it has memory, it needs the information from the past, but that does not mean that it is not instantaneous. Here, the instantaneous voltage of the voltage, the instantaneous value of the capacitor voltage depends upon the past value of the current. Similarly, the instantaneous value of the charge depends upon the past value of the current. So, is that clear?
Okay, sir.
Okay. But it is the instantaneous value. This is Q at that instant t, but it is dependent upon the area under the curve until that t. So, you have to consider area under that curve to get that value at this instant t.
Okay,
Okay.
sir.
So we'll solve another problem, maybe some interesting problem. All these are straightforward. Okay, we'll see. This is one very good question. Similar type of question, but we have here inductor and capacitor, and we'll see. Now you start writing. So this is question 5. Okay. So now forget about whatever is given in that I1 curve, whatever. You just have to always write the expression of the voltage and current relation. Okay. So this is our question number 5. So they are asking the voltage V1 at t equal to 5 millisecond. The capacitor and inductor current are 0 at t equals to 0. So V1 is equals to VL plus VC, right? Agree?
Yes, sir.
So now I'll substitute. What is VL? LdIL by dt, right?
Yes, sir.
So L into DIL by dt. And what is VC?
1 by C integral
IDT.
IDT.
Okay. Now again, the instantaneous value of VC at t equals to 5 millisecond is dependent on the past values of current. So that's why we are getting this integral. So now we will solve this individually. So this is say VL and this is say VC. So we'll try to calculate this individually. So first I'll calculate VL. So VL is equals to L into DIL by dt, and the slope at what time? At t equals to 5 millisecond, right? So L is given as zero point 0.1 Henry. Can anyone tell me what is the slope, value of slope at t equal to 5 means at this instant?
-5.
Others agree? Hello? So this is how much? 5. And this is how much? 1. And the slope is y by x. And there will be a negative sign, so it is -5. Okay. So this is minus 0.5. Agreed? Hello? Agreed?
Yes.
So that is VL. Now let us go back and just take the picture of this. Okay, so now we are going to calculate VC. VC is nothing but what? VC is 1 by C integral I dt, and the time is until 5. So again we have to do area under the curve, right? So again I'll check which and which area will get cancelled. Okay. So now this area and this area have the same magnitude but opposite sign. Agree?
Yes, sir.
Similarly, this area and this area has same magnitude and opposite sign. Agree?
Yes, sir.
So now what is the area under the curve?
Yes.
5.
5, right? Agree?
Yes.
Okay. So 1 by C. 1 by C is how much? C is 2 micro. 2 micro into area under the curve is 5 what? 5 milli into milli. So it is 5 micro. So this is how much? 2.5, right?
Yes, sir.
So now what is the value of V1, which is VL plus VC?
2 volt.
V1 equal to VL plus VC. That implies V1 is equals to 2 volts. So first you have to always write the voltage current relation and then solve according to the information given in the question. So always try to do that. So is this question clear or you have any confusion?
Yes, sir. Clear, sir.
Okay. So someone in the chat has asked some question. Let us see what is that question. Okay. So how to find VC in this? Okay. So let me just take a screenshot and then we'll solve this question. Sir, these graph questions, I have difficulty how to improve this. So one thing I would always say, whenever a graph is given, don't be afraid of that graph. You always try to see. I'll tell you how I'll solve from my perspective. Then maybe you can use that. So this is today's question. So first I will see. I'll not look at what is the graph that they have given. First I will always see what is given in the question and what they have asked. So they have given current, right? IC is given and they are asking VC. So first I'll basically write I is equals to C into dVC by, sorry, dVC by dt. But one thing you should keep in mind that if this is IC, then this is the polarity of VC, right? Agree? But here they are opposite. So you have to keep a minus n because current, if this is the current, then this is the polarity, but they are opposite. So there will be one minus sign. Okay. Now from this I will do VC is equals to 1 by C into integral I dt with a minus sign. Agree? Whoever has asked this question.
Yes, sir.
Okay. So now first I have obtained the relation between VC and IC. Now I'll go back to the graph. So I know that integral I dt is nothing but area under the curve, right? Agree?
Yes, sir.
So now I'll calculate the area under the curve, which is 5 micro. So this will be minus 1 by 100 micro into 5 micro. So VC is 1 by 20. I think it is 50 millivolt. VC is 50 millivolt. So always you should first see from the, so irrespective of this graph, my concept will not change, right? Concept will always remain the same. So first you have to always get the expression. Same thing I am doing for every question, irrespective of whatever is the circuit, the approach is always same. So for this current and this for this set of arrangement, what is the voltage expression in terms of currents? So here it is L and C, here it is only C, but here there is a tricky part, which is current direction is opposite. Whichever terminal the current is entering, that will be positive. So actually this terminal should be positive, but they have given this as positive, right? So that's why there is this minus n which I have missed. So minus and minus. So first I got the relation between I and C. Then I have seen that it is the dependent on area under the curve. So then I have done area under the curve. But what happens if they have not given I as a graph? What happens if they have given I as a function? Then you know the integration. So now you will do the actual integration. But as far as they have given a graph, don't integrate. It will waste your time and you will make mistakes. Area under the, if there is a graph, integration is nothing but area under the curve. So you solve geometrically. If they have not given the graph and they have given a mathematical expression, then only you solve mathematically. Here also you can solve mathematically, but that will unnecessarily waste your time and you might make mistakes. So here it is very simple, right? This and this will cancel, this and this will cancel. This is a square, area is sorry, this is a rectangle, area is L into B. If you solve mathematically, it will take a lot of time and it will unnecessarily waste your time and you make mistakes. So that's how you should approach a problem, any problem. So I have solved only few problems. Say they have given this problem. Again, same. Irrespective of the graph, I know voltage across a resistor is I into R. And voltage here is 1 by C integral I dt. Then I will come back here and I will see for the voltage in a resistor, I have to calculate the instantaneous current. So they are asking at this time. So what is the instantaneous current? Zero. So the voltage in the current is zero. Then voltage across the capacitor is area under this curve. Then again, I will see the area under this curve. And then I'll find area of this individually and see what is the area. And then I'll divide it by capacitor. If you directly look at the graph, I know it is a bit like scary. So don't look from that perspective. First, you solve this circuit, get the expression, and then correlate with the graph. So is that clear?
Yes, sir.
Okay. Any other queries?
Sir,
Yeah.
in that mutual induction
Yes. Mutual.
equation is there, right?
Yes. Yes.
In the first case,
Uh-huh. Okay. Let me go here. Yeah.
Nice. Both the dots are in down means how it will turn, sir. First case. In that.
So you are asking some other for this, or like in this question only you are having a doubt?
No, no, sir. In that case, you explained that, sir. If the dots, based on the dots, we can change the polarity, right, sir?
Yes. So if the convention is dependent on how the current is entering, that they are not dependent on whether the dots are on the top or dots are on the bottom. It is said that whether the currents are entering the dot or leaving the dot. So the dots can be on the top, dots can be on the bottom. But here, if you see, the dot is on the top here, dot is on the bottom in this coil too. But in both the cases, current is entering. So that's why it will fall under case.
Sir, if we take the in this sum, if we
Yes.
take the current in opposite direction, that will be I2 in the upward.
Yes.
So it is leaving, right, sir?
Yes.
So it will get L1 di1 by dt minus M di2 by dt, right, sir?
Yes. Yes.
Uh, so if in the I1 the dot will be in downwards means the yeah I1 di1 by dt will be minus or it will be same.
Okay, okay. So let us just consider this and then we'll draw again. So I'll proceed with you tell me how you want the current direction. So I1 you want it to be the same or opposite?
I1 will be the same, sir, but the
Okay,
dot will be in downwards.
okay. So I'm writing this so whenever if someone directly goes there, they will know that it's a doubt. So let me erase this. Okay, I have
Yes,
erased
sir.
this. So you want the dot to be down. Okay,
And then both the currents are in the same direction.
same direction. So they are either entering or leaving. Okay. So here the current is like this, here also the current is like this. This is your doubt, right?
Yes, sir.
Okay.
Yes, sir.
So this will also fall under case one. Why? Because currents are leaving the dot in both the cases. It is either entering or leaving in both the cases. Okay. But what will be the
Okay, sir.
change? The change is this is positive terminal, this is negative terminal, this is positive terminal,
Yes,
this
sir.
is negative terminal. And entire things remain same.
Yes, sir.
Only if it is entering in one case and if it is leaving in the other case. Say if the current is in the magenta, then this terminal will have positive and this terminal will have negative. If the current is in the direction of this green color, then this will have positive and this will have negative. So now let me show you something. So in the case of red color, in the case of red color, what is the expression of V2? V2 is M into di1 by dt, right?
Yes, sir.
Yes. So now let us take the green color. What is the expression for V2? Minus M into di1 by dt, right?
Yes, sir.
Okay. Now if you see the polarity of V2 is opposite. That's why we are getting this minus sign. It's not that we are not we are getting a wrong answer. If you consider I2 in this, V2 is having this polarity and this is the expression. If you are considering current direction in this, the V2 polarity is this, and that's why you are getting this expression. So now if you see this V2 and this V2 are both are same because their polarity is considered in the opposite. So no matter what assumption you make at the beginning, if you follow all the guidelines properly, you will get the same answer.
Okay, sir.
Is that clear? Yeah.
Yes, sir.
Okay. So polarity is always important. If they have not given any direction, make assumptions and follow the same assumption throughout your problem. You will get the
So
same answer.
this will be L1 di1 by dt plus M di2 by dt.
Yes.
Like that, sir?
Yes. Yes.
Okay.
Same expression.
Okay, sir. Thank you.
Okay. Okay, then someone has asked some query in the chat box, but again today we are running late. But I'll just see. I'll not solve. I'll just see how to solve. So they're asking in the circuit find the current I1 in the amperes. So it is basically an infinite series. So you have to see how the current is coming. I is going down and I2 is going up. Okay. And I4 is coming down. Okay. So it is going to infinite. Okay. This question is little bit interesting. So let us solve this. Okay. Okay. So first of all, so when such infinite number of things are there, so let us just first solve, say only I by 32 are there, only until this point is there. Say it is not till infinite. So we have I by 32 here, right? Agree?
Yes, sir.
Then
Yes,
I
sir.
by 32 is entering and I by 16 is going like this. So here you have how much? Sorry. I by 32 in this direction. Agree? I by 32, right? This is I by 32 and this is also I by 32, right? Something like that.
It will be 2I by 32, I think.
So it is I by 16, right? Current is going in this direction. Or we'll do one thing. If it is confusing, we'll come from a different view. So first we'll write, say this is I1 and this is I, right? So what is the value of this one? I1 minus I, right? Agree?
Yes, sir.
Okay. So this is another doubt. I'm keeping like this. Okay. Right. So if this is I1 minus I and this is I by 2, what will be the value of this? I1 minus I plus I by 2. Agree?
Yes, sir.
And then what will be the current in this I1 minus I plus I by 2 minus I by 4. Agree?
Yes.
Huh?
Yes, I will.
Yeah. Now
Yes,
what
sir.
will be the current in this? I minus I1 minus I plus I by 2 minus I by 4 plus I by 8.
Yes, I will.
Yes. So now
Yes, sir.
I will do what I will do. I will take this subsequently. So it will be I1 say plus I by 2 plus I by 8 then plus I by how much? 32 plus up to so on, right? Agree?
Yes, sir.
Then I'll take the negative terms. Okay. And then minus I'll take common. It will be I plus I by 4 plus I by 16 plus up to so on, right? And this is infinite
Yes, sir.
series. So now we'll know this one will become I1 plus I by 2 by 1 minus how much? 1 by 4, right? A by 1 minus R, right? Agree? Like A plus AR plus AR square plus up to so on. If R is less than 1, this summation is equal to A by 1 minus R. So here A is I by 2 and R is 1 by 4.
Okay, sir.
Okay. Then similarly, here A is I and R is 1 by 4. Okay. Something like that, right?
Okay, sir.
Yeah. So I1 minus plus I by 2 by 3 by 4 minus I by 3 by 4. So we'll have I1 plus how much? 2 by 3I minus 4I by 3. So this is I1 minus 2I by 3. So this is the current that is flowing in the infinite uh, wing, right? Something like that. Agree?
Yes,
Yes,
sir.
Yeah. So now say we have reached the infinite one. So the current will be something like this. Say it has ended. It is the final one. And now we have calculated this current, right? So this current and this current should be equal. Agree? Applying KCL? Agree? Hello? Yes or no? Agreed? Hello?
Yes, sir.
Yeah. Because now we are in the infinite one, so there is nothing on the right side. So whatever current expression that we have calculated should be equal to this value. And what will be the value of this? This value will be I by 2 to the power infinite, right? So it is always already tending to 0. So that current should be equal to 0, which means I1 is equals to 2I by 3. So is the answer matching for this? Whoever has asked.
Sir, is it understood, sir, that plus AR plus AR square, that expression can you explain, sir?
Yes, so this is a geometric progression formula that you have to understand. If it is a geometric progression with the first value as a, and the like multiplying factor is r, and r should be less than 1, and if it is an infinite series, then summation is a by 1 minus r.
Okay, sir. Okay.
If r is greater than 1, then it will not be applicable, because if r is greater than 1, it means it is incrementing, right? So the summation is not finite, summation is infinite. Only if r is less than 1, then it will converge. So it is called converging series. If the r is greater than 1, it is called diverging series, because the number will become more and more and more bigger. So summation will be infinite. Only if it is becoming smaller, then only it will become finite. Got it?
Yes, sir.
Okay. Yeah. So I hope this is clear. Basically, what I have done is I have come from the left hand side, and then I have found out the current in the infinite wing. I got the expression using the this geometric progression infinite series summation formula, and then I know that in the infinite wing, whatever is the current, these two should match. Irrespective of the direction, they should match. And anyway, this current will be 0 because it is I by 2 to the power infinite. So the current flowing through this is 0, which means this should be 0. So that's why I1 minus 2I by 3 is 0, I1 is 2I by 3. And I don't know what is the current. I think they have given 3, so I1 should be 2 or something like that. You please check the answer. I hope this is clear, whoever has asked. Whoever has asked. Kamakya, is that clear? Hello, is that clear, Kamakya? Any other doubts? Hello.
No, sir.
Okay. Yeah, so this is our first session, and that's why it got a little bit elongated because you had so many doubts, and we will continue. So this is how our subsequent 11 or next 12 session will happen. So we'll start with some concept summary so that it will lay the foundation for our discussion in the later session. So for initially we'll start with some summary so that there your doubts and any queries or confusion regarding concepts will be clear. Then we'll start with few problems where we'll understand the application of concept, how that concept will be applied. And if you have some queries, you can always write in the chat box, and then we can solve, so that it will be helpful to everyone. It is not that your query is getting solved, because this query is for everyone. Everyone will get to know how to approach that problem and how to solve it. So we will all get benefited. Yeah, sir, please provide this PDF. Yes, all these notes, everything will be uploaded to my Google Drive, as well as this recording will be uploaded to my YouTube channel. And let me share this message again. So these three links you should keep handy, and these three should be accessible easily. Then only you will get access. There I have mentioned the drive link. Please save that link. I'll upload these notes there, and also I'll upload this video by tomorrow night. I need some time because this is, as you see, it is 2.5 hour lecture recording, and it takes time to process this and upload in the YouTube. So I need at least 24 hours time, considering the other research work that I do. I promise I upload within 1 day. So by tomorrow night, you will get this video in my YouTube channel. So please go through this. And if you have any doubts, you can mention in the comment section of that YouTube. I try to reply there. And if I need something that I have to draw and explain, I'll keep that query in the mind, and in the next doubt clearing session, we can have the discussion. So with that being said, we can end this session here. And thanks for joining. It was a nice session. And we'll see you tomorrow we'll see you in the next week on Monday, 6 p.m. to 8 p.m. Have a nice day. Thank you. See you in the next week.
Thank you, sir.
Yeah. Okay, then I'm ending this session. See you in the next week. Thank you, everyone. Good night. Have a nice day.